What goes right in the middle? Yeah. The meaning goes right in the middle. And where's 140 go? And 150 is somewhere up here. I want this area between. I can't look up any areas until I make these into z-scores. Yeah. So you look for this kind of problem and you do it. This is like right now one of the more important problems, to be honest. So how to make 140 into a z-score? Could be very wrong. Oh shit, did nobody do that?
It's 127.237.
So I think what happened to you was you didn't do this.
I thought the calculator 0
Totally does. It totally does. And I appreciate the little bit of smart assishness there. But if you put this in, like this, then that's what's called garbage in. Because what am I supposed to be dividing by 11.91? This difference, right? So the disadvantage for this calculator, which is fine with me, I don't want them installing human eyeballs in this. I don't want to be able to look at a problem yet. That's freaking me out. Calculator, look at this problem. So, yeah. No. It doesn't realize that this bar is like the way it is, and the top is together. So we have to tell it it's together. That's one of the most common mistakes I see.
It's negative 1.0.
Negative 1.01, roughly, if you round it. Okay, cool. If you think about it, I mean, one step is almost 12. That's 12 down. It should be about 1. One step down. It should be like negative 1. So you should be able to kind of estimate how big or small these things are. This 150 then would be 150 minus 152 divided by 11.91. It's like negative 0.17?
Well, there's a 9 after the 7, so once you round it to negative 1.
So what was it? Negative
It was 1679. Yeah.
0.167, so 0.17. So negative 0.167, we're rounding it to, I don't care what comes after, we're rounding to this place. Why am I rounding it to do this? 2 decimal places? Because the chart goes out 2 decimal places. There you go. So I round it to this place, so it's negative 0.17. Cool. Okay. And then I can look up, so now this is negative 1.01. I know this is negative 0.17. What do I get when I look up negative 0.17? What area do I get?
0.4325.
Whoa. 4325, okay. Sorry to you. Took my brain a second. And then when I look at negative 1.01, 1539?
Yes.
Alright. I haven't heard any dissent. See some confused faces. Double check that. Make sure you can find it. Or if you can. 1562?
Yeah.
There we go. As we look at 101, it's going to be the second one over. Yeah, 1562, good. Because that first column is 100.
Yeah, that's right.
Yeah, so that's a real easy mistake. So then how do I find the answer? How to find that area between? Subtract those. Alright, so that's coming back. So whatever that subtraction is. 0.2763. Yes, sir.
Didn't you say you can never get like a negative?
Of course you can't. Where do we get a negative?
No, I'm just saying, like, how about like that was the opposite if you're subtracting like 1.5?
But it will never be the opposite. Do you understand? Because it's always the too much minus the how much too much. It's always bigger minus smaller. Yeah. Cool? Now, a problem that goes the other way would be if I said find P11 for this. What does P11 mean?
Find the probability that 11,
No.
11
11th percentile, there it is. So it's not a probability of, it's not that. P11 means the 11th percentile. What does that look like in the normal distribution? What does it look like here? Where would P11 be? Be down here. It only has how much below it? 11%. Right? So what z-score am I talking about then? So this is where it gets really evil. Doesn't 0.11 look like a z-score?
Yeah.
Can you imagine somebody looking at 0.11 and writing a number down and just going for it? But it's so wrong. That's not a z-score yet. I don't know. That's an area. That's a percentage. I got to look that up in the middle and find out what the z-score is. And then I use this bad boy, this backwards dude, to figure out what the x-score is. So 0.11, what's the closest you can get to that area?
Negative 1.23.
Yeah. 0.1093, that's the closest you get to 0.11. So we're like 7 away. And now I want to change that into a raw score because I know the mean and the standard deviation. So now I can I start at the mean, 152, and I go down, this is below the mean, 1.23 of those, 11.91. And, whatever the heck that is. It's like 137. So, I don't know.
137.35.
Some days. 137.35?
Yeah.
Oh, so there you go. It's a 0.35 now, boy. Huh? Shut. So that would mean if this was a test or something that people were taking, where the average is 152, it's like a 300-point test or whatever, then if you scored a 137.35, you would be in the 11th percentile. That would not be a good day for you, right? That's what that means. So we're doing this backwards. Normally, they say, what's the probability that somebody gets less than this? So then I make it into a z-score, and then I look up the area. Do you see how that's the exact opposite? I gave the area at the beginning. And I'm like, well, what x-score would lead me to an area of 11%? Well, I got to see what would the z-score have been. And then I can change the z-score back into an x-score with this. Do you guys understand that this formula is the same as this formula? They're exactly the same. These are the same formula. Just this is solved for z and this is solved for x. Same formula. So they do the same job. They translate from one to the other one. So if I know z, I use this one to get x. If I know x, I use this one to get z. Imagine. Cool. That's almost everything. I think the only other major things on here was the x p of x problem, but hopefully that's pretty standard kind of stuff by now, hopefully. And the idea of unusual. Currently, how far do you go out until you hit unusual? True standard deviations, I love it. So, like I told you, later this semester, that's going to change depending on the situation. Right? I want to get off my ass if I'm in a nuclear reactor. I want to make unusual a kind of a smaller interval. Like the minute that starts creeping towards the yellow on my gauge, I'm running out there to see what's happening. Is Godzilla coming? Is Bryan Cranston going to come over? That would be awesome. No? Okay. Yes? I gave you guys answer keys. Feel bad for the people on the left already. They didn't need this, so I'm sorry. 37.